All right, good day guys, you're welcome again to my channel. I am Joshua the designer. In this video I'll be showing to you how to detail a slab according to BS8110. This is the simplest video you would ever find on slab detailing. All right, so as you can see on my screen, I have a complete slab detail drawing. All right, and this is what I'm about to teach you. You are just going to become perfect with slab detailing in a minute. All right, so going through to this video, I'll be showing to you certain principles or certain things that should guide you as you go through your slab detailing. All right, so you see on my screen, I have this drawing, and now this is supposed to show you what recommendations we have going about slab detailing. On my left, which is on your left also, you see the restrained end support. So when you are around a condition and you are trying to detail anything around the restraint end support, you are to go about this recommendation. The same thing applies to the one on your right, continuous internal support. You have to stay by that guide. All right, so to make sense to you, I'm going to apply all of these in the detailing you are going to see in your screen right now. All right, so back to our drawing. Now, by now, I hope that you are acquainted with the general arrangement drawing. If you're not familiar with how to generate a general arrangement drawing, you may use this video right on your screen, also on my playlist, to get yourself perfect in generating general arrangement drawing. All right, so this is going to be an example we're going to be taking up today on the detailing of a slab. All right, so we have a simple slab setup, and it's going to, I think this is enough for you to understand how to detail a slab. All right, so this is a general arrangement drawing. And what is a general arrangement drawing? In case you are hearing this for the first time, this is a drawing that shows to you the positions, sizes, and all every information you have to know on your structural elements. That is your beams, your slabs, and your columns, and whatever the case may be. All right, so this is what we're going to be using today to explain to you how to detail a slab. All right, so what I want to do is to remove the informations that may obstruct my adventure, if you may call it that way, or my attempts to detail the slab. All right, so you want to remove this information that shows to you the thickness of the slab and the sizes of the beams and whatever elements that you have around. All right, so the informations that we only want to have left on our layout while we want to attempt any detailing are just the positions of your elements. We know the informations and we can find them on some other structural documents or drawings like the general arrangement layout, which is the layout, structural layout, and some other drawings. So this on the slab detail is supposed to carry the reinforcement details and the information of them all right, so as it is now, I've removed everything. So I want to begin my slab detailing journey. So before you start, also there are other things you need to know. You need to know what types of slab that you are dealing with. There are several types of slabs. All right, so we have one-way slab, we have the two-way slab. All right, we have some other slabs like the cantilever slab also. And because when you are detailing, you have to consider all of this so that you may be doing things appropriately. All right, so looking at this setup, for example, we have a 4 meter by 4 meter panel. Each of these are panels. All right, so you want to look at them panel by panel. All right, there are many things you need to know along this journey so that you can be a perfect detailer, as the case may be. So we have this panel. For example, we have a 4 meter by 4 meter panel, which is going to be a two-way slab. All right, so having a two-way slab, you know that all sides are primarily responsible for the support of this panel. All right, so you want to take note of that. So in case you're joining for the first time, you should like and subscribe to this channel and make comments, share with your friends, and then let us get better with structural engineering. All right, so this is the first way we're going to start. We're starting with this panel right here that my cursor is hovering over. All right, so we see that this is a two sides discontinuous slab. All right, the slab is discontinuous on both ends. So following what I just showed to you while I was explaining earlier, we see that it meets with one of these conditions here. We have the restrained end support. Restrained end support, that is the support with which there is a beam support as the end support, that is connected to a beam at that support, and the slab is discontinuous. So at this point now, we have recommendations that should guide you while you are doing your detailing. So let's take that recommendation and put to practice. All right, so with this now, it says that when we're taking our return reinforcement at the end, it's supposed to be at 0.15 multiplied by the span, which is L. That's going to be the minimum. You can well go above it, so but that is the minimum according to recommendation. All right, so let's get back to our drawing. We have the bottom reinforcement and we have the top reinforcement. So for this tutorial, I will be taking the bottom reinforcement separately, then the top reinforcement separately. Then after we are done with that, in another video I would combine the two together to form a single drawing, of which way you can do it separately. There are many people who do that separately, and you may adopt that, no issues. So with this, we have the bottom reinforcement on this side, all right, which sits on the support. Now on this side, you have to maintain a cover to reinforcement, all right, and the cover to reinforcement for slabs is 20 mm. So from this edge of the slab and the beam support, you take 20 mm away from that support, all right, 20 mm away from that support as your cover. Then the thickness of the slab is 150 mm. All right, so if you remove the bottom cover, which is 20 mm, then remove the top cover, which is 20 mm, you're left with 110 mm. So that's going to be the height of the or the length of the anchorage. All right, that's going to be the length of the anchorage. Anyways, there is a recommendation for the anchorage length also in the BS code 5. If you can see this recommendation 5.2.11.3 in your BS code, you can have further information on that, but I've just shown to you the simplest way you can go about your detailing, and through that. So to follow through the next step now, there is a guide to how much this bend, which is the return, should go in. All right, we have a recommendation from that. According to this, I know you are saying the answer already. It is 0.15 multiplied by the length of the span. Okay, so how do you do that here? What you do is you measure the center to center distance, which is 4 meters. All right, then you multiply by 0.15. Why did we do that? Because it is the end restrained setup. This is where we are dealing with. According to our reference here, this is the manual 0.15 multiplied by the end, the restrained end support, and that's why we're using this. So when the condition changes from here, we change the guideline and the reference. So we have the 0.15 multiplied by the 4 meters. So we have 600. So we take 600. That's the minimum. So if the guideline says, or the recommended distance or length says minimum, it means we can go above it. All right, so but we stay at that 600 for the purpose of this tutorial. Now this has perfectly explained what is going on here, and I believe you get that. If you're confused or you have information or questions around this, you may please use the comment section. I'll be right there to answer to your queries, to your questions, and to your comments. All right, thank you. So on the other side, the same thing apply. You have a reinforcement spanning all through to the next support. All right, and then you take the cover, you take note of the cover, and this cover is for the purpose of resistance to, not even resistance, or you want to keep your reinforcement safe from exposure conditions. All right, the conditions might be mild, might be severe, or really, really harsh, then it might affect your reinforcement. It might cause it to begin to corrode or expose to the atmosphere. All right, so but you want to keep it at a clearance from the face of your structural elements, and that's why we maintain cover. And I made mention that the cover is 20 mm to the face of your element. So that's 110 following our calculation. All right, then by the rule of the restrained end support, we have 600 on this side also, because the span here is also 4 meters. I believe you're clear with that. So I made mention earlier that I'm going to only do with the bottom reinforcement in this video. All right, then in the next video I'll do the top reinforcement, then subsequently I'll do the combination of the three to give this kind of arrangement, which is the final. All right, so let's proceed. Let's continue. Now I just used it to explain the reinforcement to you. Now let's bring out the information. So following your design, there'll be the required area of reinforcement, area of steel, according to your design. That's why you have all of this information here according to the design recommendation. All right, so it gives you a lot of information that you should apply when you are detailing. All right, so if you want to apply this, for example, and this is just a detailing tutorial of which you are just taking a typical example, right, of the result of your design. This is not necessarily what will support this slab. Okay, so if we take this information, for example, it's going to span from there to there. All right, from this place to this place. As you can see, that's telling of the of this reinforcement, of this vertical reinforcement. So let's assume that it's a 200 mm spacing recommended by the design, after the design, and the span here is 3775. What you just do is divide 3775 divided by 200, then you had 1. All right, that's going to give us 20 y12. You may name this 01. All right, and this is a bottom reinforcement, not top reinforcement. All right, so because this is the mid span reinforcement, the top reinforcement at the support reinforcement. All right, so on the other end, I'll just need to change the color of that reinforcement. Let me just mark this property. All right, so and this reinforcement may span all through, because the same thing would apply to this panel. The same thing that happens here would apply to this panel. If you want to do it, the same thing you did here is what you repeat on this other side. And instead of doing that as a double attempt to create the same solution, why not just copy what you've done earlier to make your work faster? Because as you detail, you may have complex slabs you want to deal with. You have to find a means to do the right thing at the fastest pace. All right, so and this is one of those things that will help you achieve that combination of fact. All right, so we might have on the other side something like the vertical pointer. All right, I'm just trying to use this to help us save time while you are learning how to detail. All right, so it starts from the top here. All right, so from the top, then this spans to the bottom. That tells of this reinforcement. Then it goes all the way. Yeah, I want to take all my information to the left instead of taking it to the front. All right, All right, so if we're going to do the same thing we did on the other side, we're going to just do the same attempt we used in getting the number of reinforcements. Then it's going to be 20 as we obtained earlier. All right, so this 200 if we're using the same spacing. All right, so and being the same span, this also, like I explained, in making your work faster and working smarter, might also or will also apply to this span. Then I can have this extend downward. Just these two reinforcement has been applied to, or have been applied to different panels, right? So that has solved the bottom reinforcement. So this would have been like this. For the purpose of this class, I will need to show you so you can understand. This would have been like this, but it's not necessarily, and it doesn't make your work look better, all right, to have the same reinforcement tell of bring the same information twice. All right, so you can just use a reinforcement to tell this information that you have. This one could have also been like this, but it's not necessary. Just a reinforcement is fine for what you want to do. All right, so it would have been like this, but it's cool enough to have it this way. Another way you would have done it, if you want to make your work simpler and necessary to have double information, which is for me not really necessary, is to make this separate. All right, then you bring this information just as you have here, you bring it down to have this as a separate reinforcement. The same thing you do to this one to have it as a separate reinforcement. Then you call out this separately on this side. You call it out separately on this side. You see that now? So if you are going to have the vertical reinforcement for this panel, now what we have done for this panel or on this panel is going to be on the other side of this. How do I mean? This is the restrained end support on this side. So if our reinforcement spans to this place, for example, you have to just maintain a cover on this side, a cover of 20 mm, then the anchorage length, as I explained earlier in this video, of 110. Then you have the return length, all right, the return length of 600. You see that now? So that is how it works. Now, but on this side is going to be a different case because this is not the restrained end support, is a continuous support. All right. So, or a cantilever support rather. So your reinforcement is going to span like this without an anchorage because it's still within the slab. Now, but the calling out of this reinforcement now will be such that this comes here separately but points to this reinforcement now, and then this also points to this reinforcement. All right, so that's how it works. So to change this, let's just match it. Pardon me. So that is how we've sorted out the bottom reinforcement on this side. Then to have the other horizontal reinforcement for the right panels, for the panels on the right, what we'll do is to have the same thing done on the left but on the other side. Instead of doing this thing, you might just have, since it's the same reinforcement type and the same span, you might just come and mirror what you have here on the other side. All right, that's one of the ways to work smarter. All right, instead of coming to draw and return again. If you're going to draw and return again the manual way, what you do is you just have a clear drawing just like this. You maintain the cover just like I said in the other attempt. Then the anchorage of 110, that's 110 mm. Then you have, according to our guide, that we're following, you have 0.15 multiplied by the span. All right, so you have 600. 0.15 multiplied by 4 meter is 600, and that's how you would have had this type of reinforcement all again. So instead of doing that, a mirror had done it for us. So it makes our work faster and then smarter. So we just have to, then it would have been the same for the other panel here. Yes. So what we would have done now is take this and copy down here for the call out. So we have this to that reinforcement and then this to the reinforcement. Yes, it makes more sense this way. Then we can have a call out on this side. All right, so this calls this reinforcement out. Then we can make the same attempt to call out that on the upper side. All right, and this is it. So that's great. This have helped us with the bottom reinforcement of this four panel. So let's talk about the cantilever reinforcement now. All right, that's another kind of slab. All right, so we've dealt with those that have the restrained end support. When it has to do with the top reinforcement that I'll be showing you in the next video, I'll deal with the interior support and how do you cater for the interior support. And now I'll be showing you how to detail a cantilever slab. All right, so what you have here on this side is a cantilever slab, different from these slabs that we have been doing together all the while. So but this is quite different. And what's the difference? Looking at our guide, there's a guide for everything you do in engineering, and this is the beauty of it. So this is the cantilever slab. All right, this is the support you're seeing here. All right, and the cantilevers with this length K. This is what you're saying, cantilever length K, and the span, interior span L. All right, so how do we detail that? A cantilever has a return of 1.5 of the length with which it extends beyond the support. 1.5 multiplied by K, and where is the K? K is the cantilever length. So the return of that reinforcement, as in the case of the one we did previously of the restrained end support that has 0.15 multiplied by the length of the span, but in this case it is 1.5 of the cantilever span, or 0.3 of the length of the interior of the span of the interior support slab, 1.5 of the length of the cantilever, or 0.3 of the span. So with this, we can begin to see how to go about our cantilever support. Now, we have, following what we just did there, this is the cantilever support, maintaining the cover of the slab 20, which is from the face of whatever element you're dealing with. And the anchorage remains the same, 110. Then, this is where the deal is now. Going back to what we have here, we have from the face of the beam, you have 1.5 multiplied by the length of the cantilever. Now let's apply that to what we have here. The length of our cantilever is 1312.5, just like you have here. The length of the cantilever from the center to the end of the cantilever, you have 1313. So what we do is 1.5 multiplied by 1313, that's 1969.5. remember, that's the minimum length of the return, so it means you can go beyond that, which I would like to put at 2 meters. All right, so that's how long your cantilever return reinforcement, the return of your cantilever reinforcement should be if you want to have a safe and good structure. So with this, let's just call out that particular reinforcement. So we have this. Now this will be, because it works as top and bottom, all right, in its functionality. It works as top and bottom. Now to have the distribution of the bottom of the cantilever, now we just have to create a reinforcement that goes horizontal. Then mind you, you have to keep the cover, all right, because it's necessary for all that you do in the detailing. All right, cover of 20 mm for your slab. Then we do this. Great. Now to call this out, what we just need to do is to do this, and then on the other end, and then we'll be good. All right, so we have this, and one of those things you should pay attention to while you are detailing is to ensure that your work is as neat as possible, because it tells of whatever information you're passing, and tells of you that is passing the information. All right, so we have this as a distribution. Now in this case it is bottom distribution. Bottom distribution. So for the number, you measure from here how much it has to span, which is 1 2, then 1 2 divided by 200, which is the assumed area of steel, spacing of the steel recommended from the design. All right, so that's going to be the 7, 6 plus 1, that's 7, y12, bottom distribution. All right, but in any case, there are some designs you begin to find around that has B1 B2. The essence of the B1 B2 is to tell which of the reinforcement comes first and which comes after. All right, for example, after we have done this, instead of this we have B1, and this becomes B2, for example. So as we have done this, we have been able to detail the bottom reinforcements and the distribution, all right, for this slab arrangement. All right, so we may just call this, give it a title as this. Call it bottom reinforcement slab detail, so that while we come in the next tutorial, we'll be able to design, or detail rather, the top reinforcement slab detail. Then consequently we put together the bottom and the top reinforcement slab detail, and then it makes more sense. If you have questions around this, you may want to use the comment section. You may want to query, make some addition. I'll be there to answer to all that you have. Do well to subscribe and like this video. See you in the next video. Bye.